Good morning to all. Today I am going to explain batch process and continuous process. We already finished the different topics like the feedback control system, which is called as a process control block diagram, and what are the parameters in that and what are the variables in any process industry. We all seen those topics. Now we'll go for batch process and continuous process. What is mean by batch process? So batch process, in order to get a particular specific product, we are going to perform the different operations in a particular materials to get that particular desired output. That is called as a process. But what is meant by batch? We are going to produce the different outputs in the form of batches, not in the form of continuous output. For example, like previous examples I taken, which is in homemade, we are going to make a tea. So whenever you want to get a perfect tea, you are going to dump the different materials like milk, tea powder, sugar, water, whatever the materials you are going to require. Those are going to dump in a particular vessel. After that, we are going to process that and we are going to get a desired output. In the same way here, in order to get some particular output or in order to make a duff, for example, a flour duff, there we are going to add some flour and then water and then salt. Those are mixed together and that will form a duff. So in the picture that shows, which is having a tank and which is having a switch, like low level switch. So finished tank. So in that we are going to perform the total operation, and above tank here two valves are there, which is a solenoid valve A, solenoid valve B. So this is, I am showing here, this is a solenoid valve A. So solenoid valve A, from that we are going to get one product or one material, and solenoid valve B, from that we are going to get another product, another material. So those two materials are added here. This is a solenoid valve A. From here we are going to get one material, and solenoid valve B, that is nothing but a valve or pipe which which flows the material. So these two materials are added here, and those two materials are combined in this finished tank. This will produce as the actual output. And here this is a start button to start the process, this is a stop button and to stop the process. So whenever you want to get the output, you are going to add two materials. We are going to add the materials and that will generate the output, and after that generation of output, that will sit idle. So this is called as a batch process, a process in which the materials or anything, those are stationary, nothing but those are not flow in anywhere, just those are stationary in a particular vessel or tank. They will process that inside and that will generate the output product. So this is about batch process. I will take the another example also. Here this is a discrete filling and batch counting. So here, which is a Coca-Cola industry, let us take, which is having a belt, and here those are Coca-Cola bottles, let us take. So all are filled continuously, but these 7 bottles are labeled and these are taken in one container like a batch. Are you clear? So up to the filling of the bottles, that is continuous, but here we are going to place those bottles in a particular cotton or particular devices like. So we are going to place all the bottles, all 7 bottles together in a particular vessel. After that will transport. Again 7 bottles came, those are labeled, and again those are filled or those are dumped in a particular cotton. After that will be transported. So this type of process is called as a batch process. Here drum filling application, nothing but this is called as a drum. We are going to perform the different processes in this. So this drum, which is having the input of 3 materials. So these three materials, those are pumped into the drum by this pump, and next one transmitter that will dump here and that will make a product. So this is also a batch process. So here you see which will having mixing of a materials. Here we have one material and two material, and here third material and fourth material. These two materials we are going to take from one pipe, and these two materials we are going to take from the another pipe. These two are added or mixed in a particular tank. Nothing but if you perform a operation, or if you are going to get the output from a particular tank or particular vessel. So those materials are stationary. If those materials are stationary, then that is called as a batch process. So there is no movement of a materials while processing. Just while filling that one, that materials will move. So while processing that particular materials, those are stationary. So after processing, those will generate the output. So this is about batch process. Once again I am repeating. So batch process, in any batch process, the materials or workplaces, those are stationary at particular place, and they will perform the operations of that particular materials, and that will generate the output. After that, that will sit idle. Again, if you want to generate the product, then again you need to dump the particular materials in that, and then that will process. But in the continuous process, not like that. So here the main advantage of the batch process is a variety of different products can be made using the plant. So we can add the different products, or we can generate the different products by using this batch process. So slow reactions can be carried out here. So while first that need to perform the operations, that need to fill it first. After that every process will be done. After that will generate the output. This entire total process or total scenario, that will take some more time. So slow reactions. So whenever slow reactions will take, that accurate output will that will generate. Like can use reactants in any state, including solids also. So whenever you want to take some, if you want to produce a product, so there you are directly you can give the solid materials also, not pulverized form or like that. So if you want, you already seen some power plants. So in that power plants, for example, you take a thermal power plant. So thermal power plant, there that power will be produced by coal. So coal is a raw material which is having a solid materials like big stones like that. But in order to generate the product, in order to generate the power here, we need to boil the water. In order to boil the water, we are going to use that coal as a material. So coal we are not going to give like a raw. We are going to powder it, and we are going to convert it into the pulverized form. We are going to convert it into powder form. So we are not giving in such a way, that is a solid material we are not giving. So in batch process, we can give that type of solid materials also. But all power plants are continuous processes, not batch processes. Okay, so that is a main advantage of this batch process. We are going to give the solid materials also. So but what is the main disadvantage of this batch process? Here the risk is more. Risk, nothing but if you want to get, you are going to dump the different materials in particular vessel, but that will processed and that will not generate the accurate output. Then what happened? Entire output, the entire product will be damaged. Entire output product will be damaged, right? So, and the accuracy is less. We are not monitoring the accuracy of the output product continuously. So that risk will be more, which is expensive, and time will be more. Nothing but expensive is all. That cost is also more. That is expensive processes. So in order to dump the different materials in a particular vessels or drums, so that will occupy more space. So that workspace will be more, or workforce will be larger, workforce will required, and larger workspace is also required. So that can be difficult to control any reactions here. So this is about batch process. So for that, to eliminate the disadvantages, our aim is to get the accurate output, right? But we are not monitoring the output here. We are dumping all the materials at a time, and that will generate the output at a time. So we are not we are not monitoring the output. So in order to monitor the output, here we are going to take the continuous processes. So continuous process is nothing but here, you see the block diagram, or you see the structure. We are going to plan. So we are going to plan how we have to do that particular, how we are going to generate the output, and then we are going to perform, and we are going to check the output, and that will take it as an output. So plan, do, check, act. This will continuously monitored and continuously generated. So there is no break of any outputs, and every time we are going to monitor the output, so accurate results will get. Okay. So here the continuous process that can be defined as the materials or the work forces here, those are continuously flow through the plant, and that will generate the output. The best example for the continuous processes, all chemical processes, all power plants, these are all continuous processes. For example, we'll take a power plant. So in power plant, is there any production stoppage? No. Every time, 24 hours by 365 days, that will generate the power continuously by applying the coal, or by, that is either hydraulic power plants or either any thermal power plants. We are going to give the input like water, coal, whatever that required. That will generate the temperature, and that will rotate the turbines, and that will generate the power. So this is a continuous process. After generation of power, we are going to cool down the water, and again we are going to reuse that water as a steam by heating that particular water by applying the coal. Okay, so nothing but which is a cyclic process. This cyclic process is called as a continuous process. So after generation of output, obviously we are going to monitor that one. So whatever the errors we are going to generate, and is there any deviations from the desired outputs, obviously we are going to monitor, and we are going to check the exact, or we are going to analyze the output in a particular way. So this is about the continuous process. Previously we seen the block diagram of process control instrumentation, which is like a one process is there. I'll show that diagram. So this is, which is having a plant that will generate an output. In order to monitor, on in order to control any output or any particular desired value, you need to measure that one, you need to compare it. That will take the decision by the controller, and that will affect the plant. So is there any gap, or is there any time being, or is there any batching of particular outputs? No. So that output generation, measuring, controlling, affecting, these are all continuously monitored and continuously analyzed. So the best example for the continuous processes are all process control industries are maintaining the continuous processes. Okay, so now we'll see that continuous process diagram. So this is same diagram. Here we are going to take, we are applying the input parameters to the process. So these are the input parameters of the process. We are going to apply to the process, and we are going to get the output variables. So in order to control these output variables, we need to measure that one, and actual whatever you want, that we are going to give. These two are compared, and these two will take the action. That controller will take the action, and is there any input adjustments are there, that will be adjusted. Nothing but final control action will be taken. This entire system is called as a continuous process control. So that will continuously monitored and analyzed. Nothing but continuously that will regulate the output accurately. So this is called as a regulatory control or continuous process control. So here I use the term which is a regulatory. So what is meant by regulatory? What is meant by self-regulation? So regulatory is nothing but in order to tune the values to our desired value, to our desired speed. For example, I'll take a fan. So in order to vary the speed, and for example, our room is very cool, so I need to operate that fan in one mode, that is 1 point. So I need to regulate, or I need to vary that regulator at 1, right? So in the same way, regulator is nothing but according to our requirement we are going to change the values. We are going to change the values. Here you see output that will generate. So this output will be measured, nothing but our speed of the fan we are going to monitor. So నాకు speed ఎక్కువ ఉంది అని అంటే I'm going to adjust by using regulator, right? So అంటే I need to I'm going to measure the output value and I'm going to take the controlling action by adjusting the regulator. Adjusting the regulator is nothing but we are going to adjust the input parameters. So this automatically that is doing the regulatory operation. So this is also called as a regulatory control. So the main advantage of the continuous processes is this is more cost effective, and there is no requirement of large quantities, and this will require less time when compared to the batch processes also. So obviously this is no large quantities are required, so this is no expensive compared to the batch processes, and all automated industries are called as a continuous processes, which will eliminate the labor. So which will eliminate the labor, nothing but the employee will be reduced, nothing but cost expensive will be reduced. So the main disadvantage of this continuous processes is while installing that particular process, and if you want to construct that particular process, that will more expensive, that is high capital cost of setting up the plant, and cost rises if plant is not operated continuously. And if we shut down the process, then that entire electrical systems are gone, that will require that servicing cost will be more. These are the main two disadvantages, but rather than the batch process, continuous processes is very preferable. So next, these are the factors. Some factors are affecting like in the continuous processes or batch processes. Here, cost of factory equipment. So factory equipment is high in the continuous process. This is very low in the batch process. So whenever we generate the continuously, and we are going to generate the output production in continuously, so obviously rate of production is high. So rate of production is low. Why? Because here we are not generating any continuously. Whenever you want, you are going to generate the output. So the rate of production is low in the batch process. Here, shutdown times, nothing but we are going to operate the process or the industry in continuous. Is there any shutdown? We are not stopping that industry, right? So the shutdown times are very less or rare in the continuous process. So in batch process, whenever you want, you are going to switch on that one. So their shutdown process or shutdown times very often. So workforce. So workforce here, entire in continuous process we are going to do in automatic way. Automatically that will generate the output in order to control that particular parameter, that will measure, that will compare, that will controls entire, that will continuous, that is controlling manner, that is automatic way. So there is no human involvement there. So workforce will be a few people. But here in the batch process, so in order to take some bottles, in order to capping or in order to labeling some particular Coca-Cola bottles, we are going to dump into a particular cotton materials that manually do, that human will involving in that process. So if you want to fill the more cotton boxes, more number of people will require, nothing but workforce will be many in the batch process. So obviously here also people will needed in the continuous process, but less number of people is needed. Here more number of people are needed. So easy of automation, which is relatively easy. So automation entirely that is related to the continuous processes only. In the batch process, that is difficult. We are not controlling there, no, and we are not operating in the automatic way. So this is relatively difficult in the batch process. I think this is very clear that about your batch process and continuous process. So you remember one point, in batch process, the materials and work forces, those are stationary at particular place. Batch process, if I ask about batch process, just in your mind, that should, which is a workplaces or work materials, those are stationary in a particular vessels or tank, that will perform the operations in that, and that will take the output. So that is main operation of a batch process. Continuous process is nothing but all process industries are in the continuous process, which is continuously monitored and which will continuously generated. So next we'll go for self-regulation system. So what is meant by self-regulating? I already told that regulating is nothing but according to the user requirement that will change the values. Regulating, we are going to tune or we are going to change the values according to our requirement, that is called as a regulating. So what is meant by self-regulating? For example, a system is there. So a system that will perform the operation that will generate the output, right? So that output is continuously we are going to analyze that actual output product, desired output that should generate. In order to get that one, we are going to measure, we are going to compare like that. So if is there any deviation between our actual and our desired value, then we are going to change the input values and that will affect that particular process. For example, here I shown in the first system, which is a stable system. Why that is called as a stable system? Here I taken a unit step signal. So unit step signal, which is I indicated in a dotted line. Okay, that is my desired value. Here actually my output is getting like this, but it finally here you see first curve that is having more deviation. So more deviation, then that input parameters are changed by the controller. So again that will reduces the curve, reduces the deviation, and again that will check, and again that will monitor, that controls the deviation, that will again reduces, and finally that will reaches to the actual our desired value. Here deviations are time to time that will deviations or time to time that will be reduced, which will be equals to the actual value, actual desired value. So this is called as a stable system or self-regulatory system. Here you observe now. Here I taken which is an unstable system. Actual our desired value is our unit step, which I indicated in a dotted line. First you tell me A. Is A output is a stable or self-regulatory system? No. Why? Because here initially deviations are less, that control will measure, but is there any reduction of a deviation? No. That will increases again, and the deviations again and again increases. So this is a unstable system, that is not a self-regulatory system. And here you observe B also. This is very much deviating about our desired value, and C is also that is very much deviated about our actual value. Okay, is it clear? This is about your self-regulatory system. So some systems are capable of producing a continuous balance, and some systems are not producing a capable of some continuous balance that will not produced. So continuous balance systems are called as a stable systems. So continuously not balancing systems are called as a unstable systems. So here the conceptual process input or block diagram. So we already seen this one. So and we are also measure the different types of process variables also, that is manipulated variable and whatever that controlled variable, load variables. So we already seen those one. But every process in for example in our daily instrumentation systems, like in any process industries, we have different types of devices, like some pipes is there, some big tanks are there, some walls are there, some vessels are there, different kinds of instruments we are going to place at one place, right? So we are going to place at particular location, and they will perform the operation. Nothing but every instrument will perform some different action. So what are the actions that will perform? Those are divided into different categories, and those elements are divided into different types like resistive element, capacitive element, like that. So before going to the topic, so what is this one? Here I am showing this is a process. So in this process I am going to give the input values, and here from here I am going to get the output process, which is like a block which is having the inputs and which is having the outputs. So here manipulated variables are there, manipulated input variables and disturbances all are at the input side. So nothing but these all called as a input variables. Input variables. So first we'll see, first we already seen the process variables are mainly divided into three categories: manipulated variable, control variable and load variable. So in that, so what are the input variables, what are the output variables? Input variables are nothing but in any for any process, if the variables are input to that particular process, those are called as a input variables. By using manipulated variable we are going to affect the process, and disturbances are affecting the process. So here manipulated and disturbances, these are called as a input variables. And here we are going to measuring the different parameters, and we are not measuring another parameters also. So measured and unmeasured, these are called as a outputs. So those all combinedly together called as a output variables. Okay. So you already know this diagram, that is a control representation which is having a process and that will generate the output. In order to control that output, we need to give it to the controller. So controller, and again disturbance is also given, and that is again given to the set point. So that will generate the output. That output will affect the manipulated variable, that will entirely affect the process. Okay, so this is one way of representation. Every concept is related to the block diagram of process control only there, but we are going to represent in different ways or different forms. So every time process is doing their work, that will generate a particular output. In order to measure that, in order to control that particular output, we are going to measure first. After that we are going to compare it, and after that we are going to control that one. So controller will take the decision and that will affect the process. In the same way, you see the second diagram now. So here the process is going on here. In order to that process is generate the different outputs. So but I am going to control only one output. So that output is measured and that will given to the controller part. So according to the output or according to the deviation from the output, that controller will take the decision. But which variable, by using which variable we are going to control that one? By using manipulated variable. So here I given to the manipulated variable, that is a wall, that is directly affect the process here. So this is total conceptual process input and output block diagram. Here every system will perform or will take the different, mainly that is divided into two elements: resistive element and capacitive element. Here I'll show, here I am showing this one. Here resistive element, now this 1-2 classes are related to the some electrical part, and how we are relating that electrical part into the instrumentation part. This is about your now from today and from tomorrow's class. Here this is a resistive element. So resistance, like this we are going to represent. Capacitance, like this we are going to represent. You already know the formulas of resistor and capacitor. Here the potential of resistor we are going to represent nothing but voltage. In a resistor we are going to represent in E1, E2, and here current passes to that one is, let us take I. So what is a R? R, that is a resistance. We can write it as V by I, you know already, V by I. But here potential V, we are going to take it as E1, E2, nothing but difference of these two, that we can write it as dE, difference, and current dI. So that is, again that formula is R is equals to dE by dI, nothing but in the form of V by I. Here V is called as a E1 minus E2 I. It already we are going to take the difference. So here we are going to take it as a I, dI. So next we'll go for capacitance. The current passes through the capacitor is I here. So here E1, E2. We are applying the potential difference of E1 and E2 here. So what is the value of capacitance or current in a capacitance? That is I is equals to CdE by dt. Here E is nothing but the voltage that we are writing as E1 minus E2. So these are the basic two elements of a resistive element, capacitive element for any process. So this is, you already know the representation of these two. How we are going to interlink with our process. So this is our actual process which is having a pipe, and this is our normal tank. This is another actual process, let us take. So here, if in your process is there any pipe connection or any flowing of a material there, that will perform or that will monitor a material that is called as a resistance here. So is there any storage capability? Is there any storage capability of your tank or any process? For example, by using this tank, you are going to store the water, right? So water is a storing element. Here, water is not storing here. Water is flowing here. Here, water is storing. So wherever the storing capacity or storing capability is there, that will produce a value of C, capacitance. Okay, you remember these points, these 2 points. Here in previous slide, just we indicated the resistance value, that voltage value in a resistance is E1, E2. Okay, so now here we are going to represent in a pipe, like this is a resistor. Let us take this is a resistor. Why we are going to call it as a resistor here? By using this wall, we can oppose the flow of a water or flow of a fluid, right? What is a resistance definition? Which is a opposition of flow of current. Here we are not using current here. We are using some liquid or some fluid. So which will resist the flow of a fluid. So in any process, if you have any pipe connection is there, then that will produce as a resistive element. That will produce as a resistive element. So let us take this. There we mentioned E1, E2, right? There we are mentioning E1, E2 here. Likewise here we are going to mention H1, H2. Okay. So output is Q here. Output is Q is nothing but what is our value? Actually we are going to that equating with the I, current I. Here current is flowing, but here what is flowing? That is flow of a water is flowing. So flow of a water, that we are going to indicate with Q. That will be indicating with Q. If for example there is no wall, so there is no wall, is there any resistive material? No. Why? Because whatever the flow you are applying, that much of flow we are going to get at the output side. Then resistance value equals to 0. If there is any valve is there, then only that will maintain the resistance value. So how we can write it? R is equals to V by I, right? In the place of V, what we have? H1, H2, nothing but H1 minus H2. H1 minus H2 by I. What is I here? That is a flow of water, that is Q. I1 minus I2 by H1 minus H2 by Q. So R we can write it as H1 minus H2 by Q. And here, let us go for the capacitance material. So capacitance, what is meant by capacitance? Here, which is a I. So I, which is a input current, and here E is a E1 and E2 here. I, what is a I value here? C into dE by dt. Okay, so C into dE by dt. But what is I here? I is nothing but Q. That Q value is flowing here. So what is E here? That is a height of that tank, that is H. So what we can write? I is equals to C into dV by dt. That is a current in a capacitor. So here I is nothing but Q. Q is equals to what? Which is C into dH by dt. C into dH by dt. This is about the capacitance formula. This is about resistance formula. You note down here. You note down the two values. Whenever we are going to calculate the resistance, there should be a wall connection in a pipe. Then R value is equals to, you note down here that R equals to H1 minus H2 by Q here. And in the capacitance, we can write the I value. I is nothing but here Q. Q equals to C into dH by dt. C into dH by dt. Or if we combine these two, we can write some Q value as, this is not that much of important, but you remember this formula. Q equals to Ka into under root of 2G into H1 minus H2, where Q is a liquid flow, you already know. K is a flow coefficient. A is the area of that particular restriction. This is called as a restriction here. And G is a acceleration. H is a head flow of liquid. H is a head flow of liquid, nothing but height of that particular tank. Okay. So just you remember two formulas here. R we can write it as H1 minus H2 by Q. We can write Q here. Q equals to, which is C into dH by dt. C into dH by dt. So, elements of mechanical translational system. So this is entirely related to your control systems actually. So I am not giving that much of explanation for this. Just I'll give you the materials. So what are the different types of materials you are going to use in a mechanical translational systems? What is meant by mechanical translational system? Any device or any particular system is moving in a linear direction. Any device is having some movement in a linear direction, then that is called as a mechanical translational system. If the system is in a rotating manner, that a system which is moving in a rotating manner, then that is called as a mechanical rotational systems. Mechanical rotational. So forget about that one, mechanical rotational. Rotational, translational, all are comes under your control system subject. But what are the different elements we are going to use in a mechanical translational system? Now we'll see. So mainly those are three, which is one, mass, damping and spring. Mass, dashpot, spring. Mass that can be indicated with M, dashpot that can be indicated with B, spring that can be indicated with K. So in order to get, for example, this is a system or this is an object. In order to move this object from here to here, from here to here, that need to move. Then how it will move? Whenever you apply force, then that will move from one place to the another place. So one place to the another place, how it will move? With the distance. So for any element, what is the input here? That input is force you are applying. That input is force you are applying. What is the output you are going to get? That is movement from one place to the another place. Nothing but displacement. What is the displacement that will occur? So whenever you apply force, if the object is moved from one place to the another place, so F acts like an input here. That movement of displacement is called as a output. Here you observe, this is a mass element, mass, which is an object. So here for that mass we are going to apply the force. Then that will move from one place to the another place with having a displacement of x. Okay, so x. But here why two dots are there? Nothing but this is having a double derivation. Here we are having a single derivation. Here we are having no derivation. So what are that one that you are going to get in a control systems? So this is a dashpot. For every mechanical element, either mass, dashpot is nothing but damping, or dashmaker spring. For any one, you are going to apply the force as an input. You are applying force as a input. So output, how we are getting? Output like a displacement. That x as a displacement. So x as a displacement. These are the three mechanical translational elements. Okay. So elements in a process dynamics, those are four types: proportional element, capacitive element, time constant element, and oscillatory element. So these we'll see in the next class. So before stopping that today's class, I'll give the brief idea about today's class. What we discussed here, in this class we discussed about the batch process and continuous process. What is the difference between batch process and continuous process, and what is a regulatory system, what is mean by self-regulatory system. And mainly, in any process industries, every particular instrument will maintain a particular elements. So what are the basic two elements, how they are operating and where they are operating: resistive element, where that occurred; capacitive element, where that occurred. These topics we covered in the today's class. In next class we'll go for the elements of process dynamics. This is very very important, which is proportional element, capacitive element, time constant element, and oscillatory element. Okay, thank you, ma'am.